Alright, so I posted these links on Blackboard to these videos. We just got lost in a commercial. And that's not the one. What happened to my video? Anyhow, you click this one here, and hopefully it won't be an ad. I hope it's an ad. We got to skip this. And I don't think I'm supposed to be showing it. It's not my video, so. And now I can skip the ad. There we go. So this video here and the following video. So this is video 1 of 2, and then we have video 2 of 2. And these are different takes on what we're going to be looking at. And so I presented this Saturday at Silicon Valley Code Camp. And I put together a really nice code base. And we're just going to work through that code base and start applying. We've been learning the language, and we're going to start applying that foundation towards doing web programming, because that's what this class is all about. So today we're going to jump in on web programming, and again, this is our same code base that we've been using on GitHub, and I'll show you where that is. But we are jumping to 99 SVCC, and we're just going to run through all of that stuff, and then maybe we'll come back because we got to somewhere right around in here, methods or something like that. So we have a good foundation in the language, and your strength in the language will grow, but it's going to grow through doing web stuff, and then as we run into things that maybe you don't know, like, hey, how's that working? We could step back and look at how like assertions work or whatever it is we come across. So that's the game plan. And the place you can find all that code on GitHub is GitHub goes to 11, and then repositories and Golang training. And so it's 99 right there is what we're going to be looking at. So let's look at the first one. No more further ado. No more life stories or philosophy or psychology or no more humanities and literature. It's time to code, build something, make money, help the world, retire, have a nice car, support your family. Check it out. Your first web page, okay, with Go. How's it your first web page? So I'm going to launch my terminal, and let me just make sure I'm recording. 219, 220. And I'm going to change into this area. And we are in 99.01. Watch this. Go run main.go. And then I could do this. For those of you who did not grow up smoking Unix. And I could do index.html. So it's going to, instead of putting the output out to the standard out the terminal, it's going to dump it to a file. And that file is just randomly given an extension of HTML. I could give it any extension, and it dumps it to a file. And I should get rid of that one first. So I got rid of that file, and then maybe I blew it. Let me just recreate it. Just make sure no file ended up there. Okay. So I deleted it as soon as it's made. Let me do it again. And now put a file there. I could open that file, and I could pop this open, and I created a web page. Whoa! That's awesome, right? And so if you look at what that's doing to create that web page, is it's just, a variable name, and then we have a string, and we're printing that string, and then we're doing some concatenation. And so right here, those backticks allow us to do basically a raw string literal. We could do a string with either double quotes or with backticks, and we use backticks because backticks allow us to keep the spaces, the return formatting, whatever. Whereas double quotes, I'd have to have it all in one line. So that's really, really cool. So I could go ahead and I could build on that a little bit. And whoops, cancel. Let's get rid of that. And here we have another one. And so name this time is coming from osargs. And osargs is a way to take arguments at the terminal. Right? So let's see what happens when I run this. So I should be able to run it in a fairly similar way. Go to O2. And here we go run main. But I need to pass in an arg, so I'm going to pass in, I don't know, Santa Claus. Right? And let's see what happens. Anything happen? Santa Claus. Whoa. All right, so we're gonna start pushing, switching gears and going a little bit quicker. All right, so you could have also built that, right? That's the way I did it before. So I could just do go build, and then it drops the binary in there. So now I have that O2 OSArgs as a binary executable, and I can say O2 OSArgs and Geronimo, however you do it, right? And this time I didn't dump it to a file. I just said, hey, standard out, and so it dumped it to standard out right there, but it put that in. So that's templating, and in web programming you need to template stuff, and that basically means you have a template, and it's like a form letter, and fill in these fields with whatever data I give to you. So I could I could cycle through all the records in the database, and for each record it fills in the fields in the template with the fields from that record from the database. So let's look at actually doing a template. And so here we have a template, and this template doesn't have any data injected to it. It's simply, hey, here's my template. And once I get my template, right, I'm going to use a couple of functions here. And the first one's from the template. Well, they're all from no, that's not true. There's a couple. But the templating ones are all from the text template library. And so if you look at the docs, there is a text template library, okay, where it gives you the basics of templating, and you can read all about it. And you have these things here called pipelines, right, where we're going to pass in data, and I'll explain those in a minute. Pipelines will become more clear to you. But there's also the HTML template library. Okay, and so the HTML template library, notice the difference there. Import HTML template versus text template, right? So the HTML template library is built on top of the text template library. So the HTML template library has everything that the text library has, but then some more. And one of the primary differences is the HTML template library is built to allow you to use templates in an HTML safe way. Okay, so we'll see how it helps protect us from cross-site scripting attacks and things like that. So here's a template parse files. So basically I say, hey, I want to parse some files. I'm only giving it one file, but based upon its name, I think it's pretty reasonable to assume that I could give it multiple files, right? So template parse files, and I'm giving one file. And when I look at what does template parse files give me, it gives me a pointer to a template and an error. And you can read about it there. Parse files creates a new template and parses the template definitions from the named files. The return template's name will have the base name and parse contents of the first file. There must be at least one file. If an error occurs, parsing stops and the return template is null. So some of that might be kind of foreign. But it gives us a pointer to a template and an error. And so if we go look at that text template library, we can look down here at the index and we can say, hey, what happens when we get a pointer to a template? Right? We get all of these methods. We get all those methods right there. Right? So the way you have a method, do we go over methods with functions? We hit functions. Do we hit methods? I think no? Yeah. So the way you do a method is you just add a receiver to it, right? Otherwise it's a function. Since you add a receiver to it, it's a method. So these all have a receiver of type pointer. They have a pointer receiver, right? And the pointer receiver means that these methods are all attached to the type of template when it's a pointer. So when you have a pointer, when you have a type pointer template, pointer to a template, you can use any of these methods. Okay? And so that's why over here, we have we get a pointer to a template and an error. We check to see if the error is not nil. So we handle the error if it's not nil. And then we do template execute. And so that execute should be one of the things that we see here. And sure enough, we see template execute, right? And it takes a writer, a data interface, and an error. So we're going to say execute a template and write it to this out and pass in some data if we had data. There's also execute template, this one, which takes a writer, a name, and a data interface. So if we had parsed more than one template, we'd say which one. And we'd use execute template and tell it which name. And so we'll see that in a second too. All right, so there's template execute, and we're writing standard out, and we're not giving it any data. So when we run this, it's just going to print out our page. We could have also done that where we say dump it to an index.html. And so that would have put it right here. And, there would be our page. So that's templates. You guys got it? You want to stop and code, or do you want me to keep going? Keep going. Okay. So here's the next thing, is pipelines. And so the pipeline allows us to send some data in. And this is the notation we use for sending data in. It's just brackets, and that's where like a template field should go, right? Like fill in some data there. And this is the pipeline. So we'll talk about the pipeline. Again, it's going to become more clear in another couple of examples. But here we have different templating, like we have mustache, right, which is templating. And they called it mustache because these curly brackets look kind of like a mustache. Or there's handlebars templating, right? And so handlebars, these are all ways you could do templating with JavaScript, or all these languages here, right? And here's handlebars, you know, again, that curly braces thing. But you can see their examples, right? Same kind of stuff. You know, so this is kind of an industry way that's common to do templating. And that's exactly what Go's chosen to use, just double curlies. And so we get our curlies, and then we can pass in some data. What data are we passing in? We're passing in 5 times 5, right? So here we parse files. We parse our template. We get a pointer to a template, and then we execute, and we write the standard out, and we pass in some data. So we're passing this data into the template, right? And if there's an error, we handle it. So you parse your templates, like, okay, let me parse them, read them, make sure I know what they are, they're ready to use, and then you execute them. Pretty straightforward. Execute it. And the first one is where does it get written, and then any data that you're passing in. So when I run this, it should, you know, create a little web thing that says 25. Kapow! 25. That's as far as I could go. So when you look at this code now, because we've spent time just sort of getting used to the language, you're like, cool, I could comprehend that, right? Cool, when I look at the docs, I could see the returns, right? I understand kind of like, hey, what this is. I know how to, you know, like, okay, parse files returns those two things. I know how to go to, you know, godoc.org and take a look at like, okay, text template, right? I know the packaging namespace, how that works with imports, how that works with godoc.org, you know, how that works with my workspace and everything after the source environment, right? If it's a standard library, when I import it, it's just this, but if it's another third-party package, it's that. And I know what these methods are, and so when I, you know, run parse files and I get a pointer to a template, wow, I now have all these methods I can work with, so I could actually start looking through these and think and see what can I do now that I have a pointer to a template. Right now we're just using one of the functions, right? But you can look through this stuff and see what other functionality is available, and you know, and maybe Google examples, you know. But pretty much this is just like the basic stuff you do. But the main point being is, because we've laid this foundation of, you know, let's take some time to understand the language. Now that we're looking at how do we actually use it, you're like, slam, 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 right? Like taking huge strides. Because, okay, cool, I got familiar with the syntax, you know. And if I showed you this on the first day, you'd be like, what? So we just had to lay this foundation of let's get familiar with the language, so now that we could actually start using it and doing some cool stuff. So here we have a template, parse files, parsing our template, and then executing to standard out, and we're passing in for data this time a slice events, right? So it's anonymous, hasn't been assigned to a variable name, and I don't know, maybe call it a slice literal, right? Because it's just a literal value. It's not been assigned to a variable. So it's anonymous slice literal. That's a pretty interesting way to describe it, right? And it just has 1, 2, 3, 4, 5. And so in my template, right, I now have this other function, range. Okay, and if I look at the documentation, you can kind of see how that works. Just, okay, I'm going to range over my data and print out each piece of data. If you look at the documentation, when we look at the templating stuff, here we have range, right? And we also have range else. You know, that's kind of interesting. But the value of the pipeline must be an array, slice, map, or channel. If the value of the pipeline has length 0, nothing is output. Otherwise, dot is set to the successive elements of the array, slice, or map, and T1 is executed. So T1 is your template. If the value is a map and the keys are basic types with a defined order, comparable, the elements will be revised in sorted key order. If the value is a map and the keys are basic type with a defined order, the elements will be visited in sorted key order. Interesting. T1, is T1 a template? I said T1's a template. I'm not sure. I don't think so because, right, like this range stuff is actually inside the template. So what is T1? That's just kind of interesting to me, the notation they use. And I don't have the answer. This isn't a rhetorical question. But here's like my first mention of T1. Right, and that really doesn't tell me the first time. T1 is executed. Otherwise, if the value of the pipeline is empty, no value. Otherwise, T1 is executed. It kind of looks like template 1, right, or template code. But that's inside the template. So template 1, define template 1, 1. So there we're actually defining templates. So defines two templates, T1 and T2. So they're using that notation there to talk about a template. But that's a little bit confusing, right? Because this is actually something you'd see in a template. But I guess this part of the templating is executed. You could think about that little chunk as a template in and of itself. I guess maybe that's what they're saying. So here's where pipelining starts to make sense. And so pipelines in programming, like, let's look that up. So, but like, pipeline is basically your current directory in Unix, right? Okay, so pipeline. The output of one program is the input of the other. That's another one in Unix, right? So one way you can think about it is the dot in Unix is like the current directory. You guys know that? And another way you can think about it is in software engineering, a pipeline consists of a chain of processing elements arranged so that the output of each element is the input of the next. Okay, so the output of one element is the input of the next. And that's exactly what we have here. The output of this element becomes the input of this one. Okay? And so this is the current element. And the current element right here is a slice of ints. An anonymous slice literal. Okay? A slice of ints. And as we loop over that, right, the output of that as we loop over it becomes the input of the next. And now this dot refers to what is the current piece of data? Well, the first time in the loop it's 1. The second time in the loop it's 2. The third time in the loop, it's 3. So that's how that dot notation works. And when you first look at that, you might be like, whoa, confusing. But it's actually really concise, nice, simple syntax, right, that doesn't clutter up your code. And it's just basically like, this one's referring to what I start out with. And as I loop over it, the output of that for each loop becomes the input for this. And that's now referring to the current piece that's being, talked about in the loop. That's pipelining. Bet you wish you smoked a little bit more Unix back in your youth. Sorry, maybe aren't the best jokes. So what happens when we run this? Control C. Kapow, 1, 2, 3, 4, 5. Ooh, right? And that's really like the basics of let me print out, all of the responses to this discussion post. Or let me print out, all of your options.
So what's the end for?
This ends the loop. All right, it's like here, range, and then bring the range to an end. Otherwise, how would it know, should this be... All right, if I had this, ba 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 ba, right? If I didn't have end, well, is that part of the loop or not? Right? With end, it's like, okay, that's outside the loop. That's inside the loop. Capiche? You want to see it inside the loop? Want to see it outside the loop? Yeah? All right. So let's code it up. And I want you guys just to recreate this template. So there's the code. And yeah, basically retype it. just so you experiment with it and getting your hands on it. And then we'll get back in and look a little bit more at pipelining and other stuff.